On Monday, October 20th, 2025, a significant portion of the internet experienced a service disruption. The event originated within Amazon Web Services' US East 1 region in Northern Virginia. The incident began at approximately 3:11 a.m. Eastern Time, when automated systems are often performing updates. The root cause was a problematic software update pushed to DynamoDB, a core NoSQL database service. The update contained an error that triggered a cascade of DNS resolution failures. Numerous services that depend on DynamoDB became unreachable across the region. Because DynamoDB underpins many other AWS services, instability radiated outward across a broad spectrum of applications: social, media, finance, even airlines. This was not a malicious cyber attack. It was an internal operational failure, a flawed software deployment. Internal changes can introduce systemic instability in complex cloud systems. A single error propagated through automation can cause a chain reaction. By Monday evening, AWS reported services returned to normal, fully mitigated around 1 p.m. ET, though some residual latency persisted. US East 1 is one of AWS's oldest and largest regions, often a default choice. Even with AWS holding roughly 1/3 of the cloud market, regional outages are not if, but when. Our architectures must account for that eventuality. The primary risk exposed by this outage is the profound danger of over-reliance on a single point of failure. In this case, the single point was a specific service within a single geographic region, US East 1. When businesses build their entire operations within one availability zone or region, they accept the risk profile of that specific piece of infrastructure. A failure in a core service like DynamoDB does not just degrade performance, it can sever access to applications and data entirely. This creates immediate impact on revenue. Beyond that, losses run into the hundreds of billions when factoring in lost productivity and delayed operations. End users rarely differentiate between your app and the underlying cloud. To them, the brand has failed. Entertainment, creative tools, finance, social, and travel all felt the pain. Silence during an outage harms reputation more than downtime. A failure to communicate transparently and proactively leaves a lasting negative impression. If monitoring, logging, and collaboration tools are co-located in US East 1, your response team is blind and unable to coordinate effectively. The most effective way to prepare is to design with the explicit assumption that components will fail. Resilience is not about preventing failure. It is about handling it gracefully. Conduct a thorough audit. Map every internal and external service and identify what is critical for core functionality. This reveals single points of failure, like a single database instance or a single availability zone, which must be addressed first. For critical workloads, implement multi-region. Maintain active or standby replicas in a secondary region. Store backup copies of mission-critical data in a different geographic location. Automated failover reroutes traffic to a healthy region, turning outages into a non-event for users. But it requires careful engineering and continuous testing. For the most mission-critical systems, consider multi-cloud. Distribute workload across providers like AWS and Azure. It is more complex and costly, but isolates you from a single provider's systemic failures. Abstract your app from provider-specific services and establish a consistent operational plane across environments. Align backups and replication to business needs. Categorize data, define RPO and RTO, and ensure mechanisms meet continuity goals. Technical resilience alone is insufficient. It must be supported by robust processes and clear communication protocols. One common failure is breakdown in communication. Define how you will inform customers, partners, and internal stakeholders. Decide channels, a dedicated status page, social media, and email, and what information will be shared at each stage. Designing failover is not enough. Regular discipline testing is non-negotiable. Start with tabletop exercises, then progress to chaos engineering, where you intentionally inject failures to validate real behavior. Use tools to simulate regional failures, validate mechanisms, and build operational muscle memory. During a regional failure, Your identity provider might be unavailable, locking you out when you need access most. Establish break glass emergency access and centralize identity across environments, with contingencies if that provider is down. Run a blameless postmortem. Track time to detection, time to resolution, and business impact, and update your architecture, runbooks, and communication plans. The recent AWS outage was a powerful reminder. Relying on a single provider, no matter how reliable, carries inherent risk. You cannot control Amazon's infrastructure, but you can control your preparedness. You do not need an immediate overhaul. Take deliberate, incremental steps to reduce risk and prepare for failure. The goal is not unbreakable systems, but an organization that can withstand and recover from inevitable failures. Start with visibility and prioritization. You cannot protect what you cannot see. Create a comprehensive inventory of AWS dependencies, classify by criticality, and identify the top 3 to 5 services that are absolutely essential, your crown jewels. Configure backups for critical data in a separate region or cloud, and design multi-region failover for essential services. Create a detailed runbook for automated systems and manual intervention so your team can act decisively under pressure. Make preparedness a habit. Test failover at least quarterly, and set up a public-facing status page and clear communication workflow. Checklist. Audit. List dependencies and single points of failure. Prioritize top services to keep online. Backup isolated copies in other regions or clouds. Plan documented failover runbook. Test simulate outages quarterly. Communicate clear plan and status page. Access implement and test break glass emergency access.